All right, welcome to Solutions, Dilutions, Molarity. We're going to make up a chemical solution, or I'm going to make it up and you're going to watch. And there's a reason I'm wearing blue, because we're working with copper sulfate. So we're going to first measure out our compound. And these are our chemical scales. And so we don't want to put the solid, this petrified solid, directly on the scale. So we put a piece of weighing paper. And if you're really proficient at origami, you can actually make a really fancy little piece of weighing paper. I'm just going to make a simple fold. It just will make it easier later when I have to put this into a container. And so these are called scupulas. And you can kind of see the scale there. Maybe not. Let me just scoop. Oh, wait. So sorry. There is a special button on the scale. Let's see if you can see it. And it's a button that either says 0 or tare. Some scales say T-A-R-E, and we just hit that button, and it zeroes it. And this scale has an exclamation mark. I found all the scales here. Turns out they're not leveled, because nobody's been here. And apparently, nobody's fixed them. And so we just add some until we get maybe too much. There we go. We write down our mass. That's how you use the scale. Now we're going to go back in the lab. You can see the lab for the first time. Right. Okay, so I started experimenting and forgot to hit play or record. So, put our goggles on, our safety glasses. I'm in blue because we're going to make a blue solution. So first thing was to get the crystals into this volumetric flask. And volumetric flasks are made so they only do one volume. So you may or may not see the white line there. That white line is the volume we're going to aim for. But first I add some water, cork it, and we're going to shake until it dissolves. And we shake for a while. And in the meantime, we're going to go through the math. All right, we're going to do the math. So, in our chemical formula, this is called copper sulfate pentahydrate. So hydrate means there's waters that were trapped in those beautiful blue crystals. So we have 1 copper, we have 1 sulfur, we have 4 oxygens. These numbers again are the atomic masses from the periodic table. And then this dot is just how they do it, and it drives students crazy. It means and, or plus, with, it really means with, plus 5 H2Os. So we are going to not multiply by the 5 H2Os, we're going to add it. So we're going to add up each of these, and we should end up with a grand total around 249.7. Now, you can, of course, just write that number down. Depending on how many place values go out, some people get 249.68, but we're going to go with 4 sig figs in this lab. I know I've been saying 3, but for this lab, we're going to go with 4, because these volumetric flasks, they're very special, and they allow us to have 4. Now, there are always units, and the mistake students will say is they'll tell me it's grams. Grams is a mass. That's what I did back in the scale room. This is molar mass, meaning how many grams per 1 mole. So whenever you use the periodic table, it's always how many grams are in a mole. It's going to be a conversion factor that we use. That's why we learned about conversion factors. So we're going to do the second step of math. So what your teacher did while you were busy is I got my crystals to dissolve, and then I added the water up to the little white line, and we can see, oh, it's going to be really hard with this because you want to look straight on. So, it's going to focus. You guys see, let's do it on the board. There is always this is our volumetric flask. There's a white line there, and I fill in the liquid. The liquid's filled in here. And then there's a meniscus, which is a curve. And so this is called a meniscus. And we always want to read the bottom of the meniscus. And so your teacher very carefully Got it perfectly there. Now, the next task is that we do some math, and we're going to figure out the concentration. Molarity is concentration of the solution. So we want to ask ourselves, what unit do we want for molarity? We're trying to solve for moles per liter. Now we're going to do this factor label. So you want to write it as a fraction. And we're trying to solve for 2 units on this one, which means we're going to have to start with 2 units. Now this is going to be a conversion factor. What we want to start with is this mass. So we have our 1.281 grams. And what we're going to put it over is the volume of our volumetric flask, which is 25 milliliters. Volumetric flasks are very precise, so it's actually 25.00 milliliters. And so in this lab, we actually can have 4 sig figs. Now, in our conversions, we want to change our grams to moles. And so this is going to go up here. The 249.7 is the grams in 1 mole, so it gets flipped upside down and goes in the denominator. And we write 1 mole on top. All right, our grams canceled. We're almost there. And then we're going to change milliliters to liters. So you can do 1,000 milliliters to a liter. There's some of you who like to do that because you're pretty good at math, or maybe you've taught your children math doing the metric. I'm going to do it with the chart. So again, you can do 1,000 milliliters to 1 liter, or if we use the chart, you would say 1 milli, right? 1 of the prefix, and then we do the 10 to the minus 3. And then we would punch this in with our calculator. All right, that will be up to you. And I can do the next step, which is our dilution step. I have to pause this again. Okay, we're back. So we are going to pipette from our little flask to make a dilution into our larger volumetric flask. And we're going to use a pipette. And some people use these pipetters. Some of you have biology, maybe had it before the whole coronavirus thing. And these work better. Everyone looks for these. There's like 2 good ones around, and there's only 1 of me. And they're labeled. So A means aspirate, which is I'm going to create a suction. So I push the A, I push my pipette, and it creates a suction. And then I put it in my solution, and it sucks up. And I'm going to get bubbles, but the bubbles will all disappear. And I'm going for a brown line that's up here. Pause and make this magical again. All right, I'm back. So I took 10 milliliters from here and I put it into our larger volumetric flask. And then I'm going to add water. So we'll do the snap of the finger. Try that again. Snap. And look at that. We added water and diluted it now to 50 milliliters. So we're going to do a dilution math. So this is the formula for dilution. The I stand for initial and the F's stand for final. So these are going to be my final value. And we're looking for the final concentration, the final molarity. And this side, these are the initial. This was what I originally calculated up here. Now, the biggest mistake students make is they put the number 25 for their initial volume. And so we did. We originally did have 25 in the little volumetric flask, but I did not take all 25 mils. I only took 10 mils. So that would be our number. And again, this lab allows quite a bit of precision. So we had 10 milliliters, and then this molarity will be this molarity, you'll plug in there, equals, you can call this X, or we can call it molarity final, and our final volume in the larger volumetric flask is 50 milliliters. So what it looks like is, oh, it's algebra. So we're going to be solving for this number. So we need to, for this variable, that's the one we don't have, so the 50 mils, we're going to have to divide both sides by the 50 mils. And most of you knew that. The 50 on this side will cancel. We want to isolate the variable we want. All right, so you would punch that in. Remember, 4 sig figs in your answer. So we're going to now see how your teacher did. And we're going to go check how close I got. All right, we're back. This is the hallway for the chemistry labs. And out here we have these special machines that allow us to read wavelength. So our solution is blue. And so we're going to see how much light can go through this blue solution. And so I set the wavelength, and right now I just have water in what's called a cuvette. It's like this mini test tube. And I set this, the top scale is transmittance. So 100% of the light is going through. The lower scale is absorbance, saying no light's being absorbed, which you would want if it's just water. So we dump the water out. We add our solution. You can gaze in wonderment at the high technology from 50 years ago. Wipe it with a Kim wipe and put it in. Did you see that? It's magical. And then I'm going to read. And we always read the lower scale for what we're doing. It looks like your teacher did all right, which you would hope. All right, let's do the genie thing. I'll see you in a minute. Snap. All right, I'm back in lab. So the graph, what I did is I found my point on the graph, and then I had to find it again because I read it wrong. And I used a ruler. I did go get a ruler, and I came over until I hit, this is called our standard curve. So I did a dot, 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 and I hit the curve, and then I came down, dot, 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 dot. And I'm looking at where I crossed the line down here on molarity. And when I read it, I got 0.0456. That would be molarity. So this was my absorbance that I read out in the hallway. And this is now my number. And so what you're going to do is you're all going to figure out how well your teacher did. You can decide if you'd ever want to be my lab partner or not. So there is a little formula for what's called percent error. And percent error is done a little bit different in chemistry and physics. So if you've had physics, just kind of bear with it. It is the actual number. And so that means the calculated. That means the number we got back in part 2 or B. I don't remember what I called it. So I'll say part B. That was in the dilution number, minus the experimental. So this is the number from the graph, which is part C. And then we divide it. So you want to do this in parentheses. You subtract first, and then you're going to divide by the actual number, which was this number, the calculated one from part B. And then you multiply by 100. And you'll get a percent. And I think it tells you, if you're not under 5%, gotta go back and do it again. And so you can decide, if I'm under 1%, I did amazing. And if I was like 7 or 8%, well, it's really fun because students will say, you know what, somebody set it up wrong. Somebody made this wrong. It was all me. I wanted to show you though real quick. This is what our lab looks like. Isn't it beautiful? It got rebuilt, say 4 years ago. I'm trying to hold it up. And yeah, we're actually putting in a letter to see if we can get back in the lab in the winter term. So hopefully I'll see you all soon. Bye. And you can absolutely come in. You should all end up with the same results. There's a bunch of post-lab where you pretend like you were here making up the solutions. All right, bye. Until next time.